This talk is organized into 3 parts. In the first part, Osaki-san will introduce our main product called Jockey and what's the issue in a wide area distributed IoT systems. So please welcome Osaki-san.
What's the issue? The complexity of creating systems and services has been increasing rapidly in recent years. In particular, the 5G mobile networks have changed from a mere query pipe to a thinking networks with computational resource called MEX inside. When we build a system, we need to understand the various computational resources, communication networks, and protocols, and then optimally assemble them. This has become a very difficult task. This is an example of a typical image processing system. Suppose an edge device processes a camera image and performs some action if it is a predetermined shape. And also, that the edge does not have enough computing power. In such a case, the edge device first acquires the image. Then, it passes the computation process to the make or cloud, which has more computing power. The final analysis results are returned to the edge. In this system configuration, we wanted to solve 3 requirements. First, the placement of modules to compute. How to handle the scattered computing resource, which are powerful, have a short latency, and are stable. Second, the programmer wants to write a single program, independent of where computation occurs. Finally, the programmer does not need to be aware of where the computation is performed. The result should be identical regardless of where the computation is performed. We propose a revolutionary framework for the era of various networks and computing environments. It is JOC, a resource-transparent distributed processing framework. Here is a brief description of JOC. JOC consists of 4 layers. Left side. First, the client layer. Abstracts devices. Next is the relay layer, which uses resource allocation algorithm to distribute it, process, and mediate message. The engine layer handles computing resources such as cloud and mimics the state of abstract devices. Finally, there is a store layer for processing data for engine layer. JOC can offload the computation requests of edge nodes in the client layer to the engine layer. It also provides an API for bidirectional communication between the client layer edge and the engine layer computing resource. This allows developers to handle computing resource transparently without being aware of the location of the cloud or make or the means of communication, making development extremely efficient. However, implementing JOC presents challenges unique to Island cluster, namely node connect challenge. First, full mesh network is not scalable. As the number of nodes increase, the cost of communication becomes prohibitive. In addition, It is difficult to configure systems that combines various networks because NAPT cannot be exceeded. We are focusing on Zenoh as a solution to these problems. Next, Takase-san.
Yeah, thank you very much, Osaki-san. In the second part, I will introduce Zenoh to tackle these issues, especially in wide area IoT networks. Before introducing Zenoh, we need to understand the publish-subscribe-based messaging model. PubSub messaging is a communication model in which a message published on a particular topic will be delivered to the node subscribed to that topic. The publisher can select the message to be sent by specifying the topic name. Also, the subscriber specifies the topic to be received. As a benefit of the PubSub model, we can construct asynchronous and loosely coupled architecture easily. In addition, because PubSub nodes can be operated independently, we can add, delete, and restart them at any time. There are two implementation types in PubSub model. First is the broker type, such as MQTT. In this type, the broker is located in the center, and it will connect communication partners and deliver messages. However, we need to know where the broker is in this type. Second is a peer-to-peer type, such as DDS. DDS is famous for robotics domain. This type of communication allows autonomous search communication partners each other only based on topic names. However, this type can be typically used only in the same network. So what is Zenoh? Zenoh is a zero-overhead PubSub store query and compute protocol for modern IoT systems. In other words, Zenoh offers not only PubSub communication, but also database management and computation as a middleware. The name Zenoh stands for Zero Network Overhead Protocol. It means that its network overhead is very, very small. Zenoh behaves peer-to-peer communication like DDS within a network, and brokered communication like MQTT between different networks. The development leader of Zenoh is Zetascale Technology in France. Zenoh is an open source project under the Eclipse Foundation. As a history of Zenoh, it was initially implemented in OCaml, but migrated to Rust in the October 2020 release. Please note that we are just users of Zenoh, not core developers. But from the user's standpoint, Zenoh is a very interesting middleware. To know Zenoh, we need to understand three keywords: eloquent, scalable, and fast. Eloquent is about communication methods. Scalable is about the network structure. And fast is about performance and productivity. As a first keyword, eloquent means that Zenoh offers several methods for the communication and storage. PubSub by push is a basic PubSub method. When a message received in a subscribe node, a callback function is executed. In contrast with PubSub by pull, the subscriber can receive a message in its own timing. PubStore get and get reply in the right figure shows the communication methods for data manipulation and computation. PubStore get offers key-value store-based computation method. And also, get reply offers RPC-like communication between nodes. As a second keyword about scalable, Zenoh protocol is decentralized and can scale out as well as scale down. We can use Zenoh in any type of topology, such as click and mesh between peer nodes. Once again, each Zenoh node can autonomously search for communication partner within the network. Also, Zenoh can behave like the MQTT protocol. Zenoh router offers a feature related to the broker. In addition, by specifying the IP address or URL of Zenoh router, a node in another network can also communicate with it. Interestingly, Zenoh routers can connect to many levels: rooted, 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 rooted. It means that we can construct a wide area distributed network structure easily. The third keyword is fast. Fast is the most important for communication. Zenoh offers low latency and high throughput communication for IoT systems. According to the archive paper published in March 2023, Zenoh could achieve 10 microsecond latency in a single machine and 16 microsecond between multiple machines in a P2P mode. Moreover, experiments in this paper confirm that a payload of 8 kilobytes achieved about 70 gigabps throughput. But why is Zenoh so fast compared with another protocol? The answer relies on the minimum wire overhead. As a packet specification, Zenoh message can be delivered with only 5 bytes frame. Finally, Zenoh runs everywhere. As mentioned at the beginning of my part, Zenoh is implemented in Rust, focusing on safety and performance. Zenoh is most effective when used in a Rust application, but there are many API libraries for various programming languages, such as Python, C, C++, Java, Kotlin, C#, and Go. Another aspect of fast is that using Zenoh is easy to run. The official web page shows the Python code as an example for your first Zenoh application. This code is surely simple as a getting start. So you will understand that we can employ Zenoh's wonderful feature in Python application. But maybe you may think, why isn't there Elixir? How do you think if we can use this wonderful communication protocol in our Elixir applications? In the third part, Shintaro will present Zeno Ex, that is the Elixir API library for Zenoh. We have implemented this library, Zeno Ex, as one of the products in our Beyond.ex projects. So please welcome Shintaro.
So thank you, Hideki. In this third part, now it's my turn to present. In this section, I explain how we implemented Zeno Ex and provide some demonstrations. Osaki-san has already provided the background. We were searching for a communication library that's over the networks, and we find out the Zenoh. Zenoh fit our needs, but it cannot use directly from Elixir, leading us to create a Zeno Ex. Our goal was to make it accessible for Elixir as well. Zeno is written by Rust and cannot be used from Elixir. In searching for a solution, we find out the Rustler and decide to use it. So Rustler is a fantastic library that bridges Elixir and Rust. I feel more easier to use the traditional NIF. However, Rust itself is quite difficult, and I had very hard. Rustler can create a boilerplate project with a mix command. Elixir and Rust builds integrated, and building with mix will also build a Rust. The Rust part of the project can be built individually, so it is possible to develop the Rust part separately. In a NIF project required build environment for other languages, and especially with Rust, the build time is so long, which is undesirable. With Rustler, you can use the mechanism called Rustler-Precompiled to distribute pre-built binaries. And you can use the library even without a Rust build environment. Okay, how to use, this is a software structure of Zeno Ex. The bottom is a Zenoh library. This library adding by Cargo. Cargo is a Rust packaging system. The second layer is Zeno Ex, NIF written by Rust. Rustler needs a notation for NIF, same as a C language NIF. It needs to implement a wrapper. And this part is a Rust project. The fourth layer is the third layer is between Rust and Elixir is smoothly connected by Rustler. The fourth layer is Elixir NIF, which pair with same name of Rust's NIF. Hence, the Elixir function is called. The corresponding Rust function is invoked. As function of NIF are very primitive and differ from Zeno API. The 5-layer align with Zeno. The 6th layer is, has not been created yet. But we are working on organizing an API that it is easier to handle in Elixir. Okay, using Zeno Ex very easy. First, you add the dependency to mix EXS and mix step-skate. This is sample code. Left one is publisher. Publisher needs create, open the session and declare publisher, and just call publisher put method. This method means send message, and left one is subscriber code. This is open the session and declare subscriber with key. And subscriber needs waiting a message. This method receive timeout is waiting message with timeout. If message coming in this line. So, okay, let's start the demo. The first demo is over the language. The demo has 5 different terminals. The top 3 terminal is subscriber, and the bottom 2 terminals is the publisher. Okay, let's start it. Okay. Can you see? Okay. Let's start the Zeno subscriber. Okay. Okay. Next is Zeno publisher. This is just Zeno. You can see the received message. The next is Python Zeno subscriber. No problem there. Okay. Next is Zeno Ex subscriber. Okay, start. Okay, you can get. That means the communication from Rust to Elixir. Okay, stop it. Next is Zeno Ex publisher. Okay. We are able to send a message from Elixir and various languages. Okay, we'll stop. Zeno Ex is easy to communicate across the different languages. Okay, next demo is over the networks. We have deployed an application on Amazon EC2. This application uses Phoenix and LiveView and Zeno Ex. We will communicate between this PC and EC2. And the Zeno router running in each environment. And Zeno and Phoenix needs a port to be opened on the EC2 instance. Okay, let's start the demo. Okay, first is running the Zeno router. And you can see the Zeno, Phoenix application in the browser. And these terminals is Zeno Ex applications. Okay, start to the Zeno Ex subscriber. And push this button is send a message from EC2 and this PC. Okay, receive it. Okay, next is Zeno Ex publisher. And this message sent from the Zeno Ex application to the Phoenix applications. Okay, of course, this feature is, can be implemented with existing method. But however, it might be quite challenging. Using Zeno Ex makes it easier and simpler. Okay, demo is over. Okay.
Thank you very much. Our feeling demo is perfect, I think. How do you think? Yeah. So feel free to contact us with your question and comment, and we would be happy if you could give advice and contribution to our research topics. And please find our repository p5g-ex/ZenoEx and take your star. Star is most important to the growth of our ecosystems. Finally, we would appreciate Pojiro-san for his awesome contribution to this library. Pojiro-san is the most technically skilled engineer for Elixir and NURBS in Japan. Thanks to him, we could have released Zeno Ex v0.2 last month. Finally, thank you very much for your attention.